Hey guys, it's Mrs. Bryant. Welcome to another flipped video in our algebra class. Today we are going to be talking about how to graph and shade inequalities. So we're going to go ahead and get started. Joey Chestnut is an American competitive eater. On average, he can eat 7 hot dogs per minute. This situation can be represented with the equation y equals 7x, where x represents the number of minutes and y represents the total number of hot dogs eaten. So it says Joey, we already read all that. Okay, so create a table of values for this scenario and graph the result. So in 1 minute he can eat 7 hot dogs, 2 minutes 14, 21, 28, 35. And then we can graph it. 1 minute he ate 7. 2 minutes he ate 14. 3 minutes he ate 21. 4 minutes he ate 28. 5 minutes is at 35. And we know it is multiplicative, so it starts at the origin because there is nothing being added or subtracted. So there's your line, and there's your graph. So is this data continuous or discrete? I've already given you the answer. It is continuous because you can eat half a hot dog or you can eat 1/10 of a hot dog. So it would be continuous. Does the ordered pair 9, 63 also fit this relationship? Well, you know the process is times 7. Even though we didn't say it, we know the process all the way down was times 7. So if we put a 9 here, we would expect times 7, 63. Our 9 checks out, and so does our 63. So does it fit in the relationship? Yes. Does the ordered pair 4.5, 40 fit in the relationship? Well, 4.5 times 7, 28, that'd be 31.5 equals 31.5, I believe. I could be wrong. Hold on. 4.5 times 7 is 31.5. Does it fit in? .5 and 40. No. The y's are different. Does the ordered pair 8 and 30 fit in the relationship? Well, 8 times 7 is 56. 56 does not equal 30, and that's what they said we had to have. So, in order for Joey to win his next competition, the total number of hot dogs he eats must be more than, so notice we have changed to an inequality, 7 hot dogs per minute. The inequality y is greater than 7x must be used to represent the situation where x represents the number of minutes and y represents the total number of hot dogs eaten. So what are some possible ordered pairs that would fit this relationship? Well, we know that y has to be greater than 7, so can I put 7 here? No, I could put 7.1, I could put 7.2. We're going to go ahead and skip this slide. We'll explain it a little bit in a second. So click the split screen to view the previous slide of the graph. So graph the possible ordered pairs. So we're going to go to split screen. And we should have had 7, 14, 21, 28, 35, 42, 49. So what do you notice? It's linear. Is it proportional? Yes. Okay, so does the ordered pair 749 also fit in this relationship? 749, yes. It lands on the slide. Does the ordered pair 4540? No. 4.540 would be, oh, I'm sorry, 4.540 would be right here. Is it part of the relationship? Yes. Because you know y needs to be greater. And does the ordered pair 830 fit? No. Below line. And this all makes sense in just a couple of seconds, I promise. So, all the possible ordered pairs of y is greater than 7x were above the graph. Any ordered pair in the shaded region above the graph, because y had to be greater, so that means we would have shaded this, would make the inequality true. Take the point 1, 10, for example. 1, 10. It lies in the shaded region above the graph. If Joey could eat a total of 10 hot dogs in 1 minute, he would be eating more than the 7 hot dogs per minute. So 10 is greater than 7? Yes. So the ordered pair 1, 10 proves the inequality statement true. I'm going to go back to full screen. So, all the possible ordered pairs were above the graph. Any ordered pair on the graph of y equals 7x would not make an inequality true. So, 5, 35 is 35 greater than 35? No. So, this ordered pair proves the inequality is false. Now, can you explain why the line is dashed instead of solid? It has to do with inequality signs. We'll talk about that in just a second. So, all the possible ordered pairs of y is greater than 7x were above the graph of y equals 7x. Any ordered pair in the region below the graph of y equals 7x would not make the inequality true. Take point 315. It's right there. It lies below the line. So, is 15 greater than 21? No, it makes it false. Okay, so in order for Joey to lose his next competition, the total number of hot dogs he eats must be less than or equal to 7 hot dogs per minute. So you'll notice the very first thing we do is fill in our table with the y equals. There's our graph. What do you notice? Does 749 also fit in? Yes. 4.540. Well, it needs to be less than, so we're shading down here. Does it fit in? No. Does ordered pair 830 fit in? Yes. It's part of the shaded region. So, any ordered pair in the shaded region below the graph would make the inequality true. 625, it lies in the shaded region below the graph, so it makes it true. When you plug it in, you see that 25 is less than or equal to 42, so it makes it true. Let's talk about 5, 35. Any ordered pair on the graph of y equals 7x would make the inequality y is greater than 7x true. Take the point 535, for example. It lies on the graph of y equals 7x. If Joey could eat a total of 35 hot dogs in 5 minutes, he would be eating an amount equal to 7 hot dogs per minute. So 35 is less than or equal to 35. That's why it is true. So, all the possible ordered pairs of y is less than or equal to 7x were below the graph. So let's talk about 3, 30. It lies above the graph, so it would make this inequality false. 30 is not less than 21. So let's go ahead and graph our own. Here are the steps. Determine the boundary line. In this case, y equals 2x plus 3. All you're doing is changing this inequality to an equal sign. So go up to 3 and put your dot. Remember, we practiced this yesterday in class, or today in class. And then our rise is up 2 over 1, or down 2 and over 1. So here's our line. And I know I can't make straight lines. Now, our y's need to be greater than this. So are we shading above the line or below? Oh, I forgot this step, guys. It says determine if the boundary line is dashed or solid. If it is less than or equal to or greater than or equal to, it is going to be solid, just like continuous and not continuous and discrete. Open circle and closed circle. If it's just less than or greater than, it's going to be dashed. I can't really write, guys, so I'm sorry. So it has that equal sign, so it is a solid line. We graphed it. Now determine which side of the boundary line to shade by testing an ordered pair on each side of the boundary line. So try 0, 0. Okay? So 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. Is that true? No. So we know 0, 0 is not part of it. Try another one. Negative 2, 2. So 2 is greater than or equal to 2 times negative 2 plus 3. 2 is greater than or equal to negative 4 plus 3. So 2 is greater than or equal to 1, negative 1. Is that true? Yes. So this point works, and the 0, so we're going to shade above. So there's just showing you. That's how you shade inequalities. Well, let's practice one more. Graph this linear inequality with two variables. So first step, determine the boundary line. So all we're doing is changing that to an equal sign. Which one is our y-intercept? The negative 4 or the negative 3? Negative 4. So 1, 2, 3, 4. There's your y-intercept. And then our slope is negative, so we can go down 3. 1, 2, 3, and over 1. Or we can go up 3. 1, 2, 3, and go to the left 1. So there's our line. Now, is it, I forgot this step again. Is it going to be dashed or is it going to be solid? The answer is it's going to be dashed because of the inequality sign. And you know I can't draw straight lines. So we know that any point that lands on it is not part of the solution, and that's where that came in. So let's test our points. Try 0, 0 again. That's a really easy one unless it goes through the origin, and then it's not easy. So 0 is less than negative 4 minus 3 times 0. Is 0 less than, well, that would be negative 4. No. So 0, 0 does not work. So try negative 5, negative 2. I'm gonna show you the work here. Is negative 2 less than negative 11? Or I'm sorry, positive 11. Yes. So we are going to shade negative 5, negative 2 below the line. Okay? So let's recap the rules. When graphing linear equalities with two variables, determine the boundary line. Determine if the boundary line is dashed or solid. And here are the rules. Graph the boundary line. Use slope and y-intercept or build a table. Determine which region should be shaded by testing an ordered pair on either side of the boundary line. Shade the side of the line where the ordered pair made the inequality true, and shade the appropriate region. That's it for tonight. Be ready to practice in class tomorrow. See you tomorrow.